So hello everyone, we are back again with next question. That's question 14 from chapter 1 of grade 10 ICSE. Chapter's name is force. Let's start. This question looks intense. You can see it's a half a paragraph question and seems very difficult, but it's very easy question. This is the question which is based on the concept of principle of moments, which says anti-clockwise moment equals to clockwise moment, and we need to know moment of force equals to force into perpendicular distance. So let's start and understand how it goes ahead. It says figure 1.33 shows a uniform meter rule weighing 100 GF. Now, if you'll see here, meter rule is available with us. It says that 100 GF pivoted at its center O, two weights, 150 GF and 250 GF. This is 1, this is 250. You can see 150 GF is trying to bring it in the anti-clockwise direction, whereas 250 GF is trying to bring it in the clockwise direction. So they are hanging from A to B and the distances are available, which is 40 and 20 respectively. The question says, first one, calculate anti-clockwise moment. So let's find out. Anti-clockwise moment equals to, we know the formula is force into distance. So what is the force available for anti-clockwise? Force is 150 GF into distance. Distance is 40 centimeter, which comes out to be 15 into 4 is 60, which means 6,000 gram force centimeter. This is anti-clockwise. Next part says the total clockwise moment about O. Now, if you'll see total clockwise moment, we'll get the answer. Clockwise moment equals to F into D again. Now, what is the force available for clockwise? This is 250. Distance is 20. We get 25 into 2 is 50, and there are 2 zeros. So that's 5,000 gram force centimeter again. So that's part B done. Next, it says difference between the anti-clockwise and clockwise. So anti-clockwise moment minus clockwise moment, answer is 6,000 minus 5,000. That's our answer, which is 1,000 gram force centimeter. Gram force centimeter. Yes. And this will move in the anti-clockwise direction. Why anti-clockwise? Because anti-clockwise is greater. This means that this figure, the ruler, the uniform meter rule will move in the anti-clockwise direction. Now, based on that, question 4 says that the distance from O were 100 GF. So now the whole setup, because this is greater, so the whole setup will move in the anti-clockwise direction. So we have to balance it by placing 100 GF. So we can't place it on the left side. We'll have to place it somewhere here. Let's say 100 GF, right? And question says how far. So we have to find out how far. Where is this? So for that, we will have to put, we have to use principle of moments, which is anti-clockwise moment equals to clockwise moment. Anti-clockwise we already have, which is 6,000. Clockwise moment we already have is 5,000 previously, and plus we are adding additional 100 gram force, 100 gram force, which is at a distance of x. So the question says find is x. So therefore we get 6,000 minus 5,000. That left us with 100x, and that's why we get 1,000 equals to 100x, and therefore x equals to, we can see calculation, it is 10 centimeters. So where do we place it? The distance, it should not be placed here, it should be placed somewhere here, this distance. So where do we place it? Therefore we place 100 GF on the right side at 10 centimeter. That's our answer. Let's check the answer. The first one was 6,000 gram 4 centimeter. Please look at the unit as well. Second one was 5,000 gram 4 centimeter, correct. Next one was 1,000 gram 4 centimeter. That was correct. Last one was 10 centimeter on the right side. Yes, this is also correct. So this is question number 14. Let's go to question number 15 now. Yes, it says a uniform meter rule. So we have to always understand that if it's a uniform meter rule, so let's say 0 to 100 centimeter, right? Then its weight will always be in the center. So that would be weight which is at 50 centimeter. This we have to keep it in mind. So it says a uniform meter rule of weight 10 GF, which means we have been provided with 10 GF of the weight of uniform meter rule is pivoted at its 0 point. So the pivot this time is at 0 itself, which means this uniform meter rule will move like this, right? Which is anti-clockwise direction. The first part of the question says what moment of force depresses the rule? So it is depressed by the weight. So moment equals to force into distance. What is the force? 10 GF, and we know this distance is 50. So that would be 50. So answer is 500 gram force centimeter. Second part says, how can it be made horizontal? So this weight is bringing it down. So if we want to apply the force, it says least force. We know least force from the pivot is the maximum distance, and maximum distance could be 100 centimeters. So least force will be applied here. That would be F. So question says, how can it be made horizontal? For that, it has to be anti-clockwise moment equals to clockwise moment. I'm so sorry, this is not anti-clockwise, this is clockwise, right? And this would be anti-clockwise. Yeah, this would be anti-clockwise. So let's check. Anti-clockwise is least distance will be, least force will be at 100 centimeters. So that is 100. And we already have the clockwise moment, which is 10 GF into 50 centimeters. So the answer is F equals to 500 upon 100. So the force needed would be 55 GF. So that is the force needed, which will be placed at 100 centimeter mark as per the answer key available. So this was question number 15. In this video, we have covered 14 and 15. We'll be covering the next set of 2 questions, and that would be the last 2 questions of the chapter. I hope you have learned a lot from these videos. Do put your questions and comments in the comment box. In the meantime, keep learning, keep enjoying. That's it from my end. Thank you and have a great time. Bye-bye.